If you're anything like me, you've casually used Linux, followed some step-by-step installation guides, used it, you're pretty comfortable, even if you use Windows or Mac for the important stuff, like gaming or managing finances. But you can't penetrate any further. The infinite how-to guides don't really offer any insight into what you are doing. A computer, any computer, executes a list of instructions to manipulate memory. Some of this memory is associated with peripherals, some contain data, some of it contains the actual instructions themselves. Every computer has to control all of this memory by hand. Embedded software engineers frequently work with these systems for developing special applications. In the early days of computing, everyone had to work at this level. If you were a grad student and you wanted to process some data for a project, you had to write a bunch of extraneous code just to execute your algorithm and see the output. The computer ran one program. That program had to do every single thing. But it's not the old days anymore. There are new frontiers, and most of us don't want to deal with all that low-level management. We still want to run our code, but we don't want to specify every memory transfer by hand. We want some kind of system to handle the details, to abstract away all those operations and give us a nice interface for running code. The computer itself still only runs a single program, one sequence of instructions. We want that program to let us, the user, insert a new set of instructions into the sequence that is already executing. The program that lets us do that is the kernel. Remember, the computer runs a monolithic program, translates to the computer is just loading and executing a series of instructions. The instructions themselves are just stored somewhere in memory. We could write a program that takes some block of memory and fills it with instructions, then point the processor to that block of memory and make the CPU execute the instructions in it. In fact, we can make this code just pause halfway through execution and store that pause location, the playhead, if you will, somewhere else, before pointing at a different block and executing that. We can repeat this and jump back and forth between as many user-injected blocks of code as we wish. This is called context switching. We can also write this one program, let's call it the host program for now, to look at the connected hardware and translate the hardware's specific communication protocol to a more general format our guest programs can understand, storing the translation in some memory location the guest programs can access. The device drivers handle the translating. The memory locations containing the translation are the lowest level abstraction layer we wanted. The kernel does all this. It controls the hardware resources, arbitrates processes, the guests, that want to interface with that hardware, and can even optimize resource usage and schedule what programs get to run when. It is the foundation, the core of an operating system. Software that sits on top of the hardware and provides a platform for other programs to be executed on while it is running. There are many different examples in the world. Linux software uses the Linux kernel. Pedantically, Linux is a kernel, which is all well and good, but we're still not here. Actually, we aren't even here yet. An operating system doesn't necessarily have general user input. Embedded systems can operate without any user input or displays, like the electronic braking system in a car. That said, we now have the background to leave the embedded world. We have the one true program that allows us to execute guest programs, which are our applications, on top of it. Well, all these fancy graphical interfaces are just that, applications. To the computer, they aren't much different than Word or Firefox. Just lists of instructions that get executed. To us, they are a portal into the system, presenting us with an interface we can easily interpret and constantly checking our input peripherals to see what we want the computer to do next. Originally, all we had was a text-based console. Fancier graphical elements grew out of that. In fact, Windows was originally just an application that you could call from DOS that evolved into a standalone OS. In order to get that full desktop experience, we need several layers of applications, each building on the programs that precede it. At the bottom is the display server. This sits on top of the kernel, listening to user input and telling that kernel what to send to the graphics hardware. It provides a framework for graphical environments. The display server specifies a communication protocol, like X11 or Wayland, that higher level software clients can use to communicate their requests to the server. The display server coordinates all these requests with the rest of the operating system. On top of the display server is the first thing we actually see, the display manager, which presents us with the login screen interface. This application lets us tell the operating system, I own this batch of files, give me permission to access them, and then load up some more applications that present a nice interface for me to interact with. The collection of applications that this loads constitutes the desktop environment. This is a major selling point for a lot of distros. Ubuntu has GNOME, Mint has Cinnamon, Arch has nothing, so on. The display manager starts the execution of a list of programs that together constitute the desktop environment. That's what we see when we're using a computer. All these elements that show us available applications, the computer's state, even the wallpaper, these are programs you can install, run, and modify. When you launch an application, it loads into a window, which is controlled by the window manager, another application. Since all the things that compose a desktop environment are applications loaded by the display manager, and since an application is just a list of instructions and resource data stored in memory, you can create your own. When the display manager identifies a user, it goes into the computer files and searches for a list of possible desktop environments. Any desktops you installed, like GNOME, Cinnamon, or Mate, will all be here. You can look at the contents of these files, which are just text, to see what the computer looks through. In this case, it looks at the exec value and tries to find the corresponding program stored in the bin directory. These can be pretty complicated, but you can make a simple one fairly easily. You just need an entry for the display manager to find, and an executable that entry points to. First, you need to add an entry to the user share x sessions directory. You do so by making a file called desktop name.desktop and then filling it with text. So you need the desktop entry in brackets, some comment describing that this is your desktop, an exec path to the program that we'll make shortly, and then the type. Now you have to write the actual program, which can be a bash script, a special type of programming language meant to be intuitive and used in the console/shell/terminal. In the bin directory, make a file that matches the execution path from the previous desktop file we made. The file extension should be .sh. Now the first line of this file should be !/bin/bash, which tells the operating system that this should be executed as a program. Then we list out the applications we want to run as part of our desktop. First, we need a window manager. I'm using kwin here. And then we can launch Plank to act as a minimal dock for launching programs. It would be nice to have a wallpaper so you can install something like Komorebi and add it to the script. Now, a bash script executes line by line, which means it usually waits at the end of a line for that command to finish before moving on. We want our application to run forever, so put an ampersand at the end. This indicates that our desktop program should launch whatever program is specified on that line, and then leave them running and go and launch the next one. But maybe I decide I don't like Plank, so I can install and use LatteDock instead. Moreover, I kind of like the LXQT panel at the bottom, so I can add that. ULauncher reminds me of Spotlight, so start that on login too. You can do whatever you want. It just takes effort. Now, if you log out, you can hit the little cog icon on the login screen, and then you can go and you can select your desktop environment. It's pretty sparse, and you can only log out by killing the last application in the list, which honestly makes me appreciate all the work these various distros do. And that's the big advantage of some of these distributions. They put a lot of work into making the user experience fairly seamless. These are huge projects that stem from the historical GNU effort, which sought to make a complete software suite that people could freely use and develop. What we colloquially refer to as Linux is a decades-long effort to create a free-use software suite, of which the Linux kernel was adopted as the core component. That's why a full-featured distribution could be called GNU Linux. It's a combination of the Linux kernel and the software derived from the GNU project. It's good to be aware of, but Linux is fine for most people. Now, that's a lot of information, but I think it's really fun to peek under the hood and try to understand these things. I almost got dragged down the rabbit hole of making my own desktop environment. People have built a lot of really cool things, and you can tailor it exactly how you like it. That said, GNOME or Cinnamon are fine for me. For now.